Right. Now, after the types of system, let's come back and learn the next property, that is the next concept, that is properties of the system. Now, again, we'll go to the same lab. You're standing in the lab. You have a test tube in your hand. Your teachers ask you to perform certain amount of analysis in the lab. There you are asked, basically in salt analysis, what do? You do dry heating test, you do flame test, you just do the series of steps. Suppose if your teachers ask you to perform the flame test, she has given you an unknown salt, you're supposed to perform the flame test. So basically that particular salt, in that when you're performing the whole experiment, there are different factors acting on the test tube. What are they? It can be temperature, it can be exchange, or they can be decrease in the volume. Okay, temperature will act. Pressure concept will act. There will be change in the color. There may be decrease or increase in the volume. Yes, anything, all the factors will be acting. Based on this, that are classified into two types of properties. One would be the extensive property, one would be the intensive property. So basically, extensive property directly depends upon the size, to what extent the reaction is happening. So it directly depends on size. Intensive properties are those which will not depend on size. It's independent of the size, depend on size. What actually is this? So as I said, you have the test tube, you have the salt in that. So mass is an extensive property. Whichever is mass dependent, that factor is your extensive property. First of all, mass. Mass, we very well know. Volume also matters. Volume also is an extensive property. Along with that, the total energy exchange which is happening between the test tube and the surroundings also is an external property. Whichever is mass dependent, that comes under extensive property. So mass dependent properties all are extensive. When it comes to intensive property, yes, the leftover. Temperature is an intensive property because that variation we can't see with the naked eye. Pressure also is an intensive property. Next comes age, also is an intensive property, isn't it? You grow by age. Color property, the color which you find the change when you heat or when you put it in the ice bath, that is also a part of the intensive property, which it is not dependent on the size or the extent of what is the reaction happening. Mass independent properties are all intensive properties. So mass dependent properties are extensive properties. Mass independent properties are all intensive properties. Let's see what happens, or what is the relation between the extensive and intensive property now. Right. So now we have differentiated extensive and intensive properties. We said whichever is mass dependent is extensive, whichever is mass independent is intensive. Right. Now again we are relating both. Extensive property per unit mass is intensive property. What does that mean? Suppose in the nomenclature I have given you one term, that is specific volume. Isn't it? Specific volume. Let us take one more, density. Okay. So specific volume, how is it denoted? Specific volume is denoted by small v. Isn't it? What is specific volume is equal to? It is equal to volume by mass. So what is volume? What do we study? Extensive property. What? Mass is an extensive property. Volume is an extensive property. Energy is an extensive property. Right? Extensive property per unit mass is an intensive property. Remember. So specific volume is an intensive property. Fine. So volume or the extensive property per unit mass is intensive property. What is the unit for this? Maybe we write it as listen, meter cube by mass kilogram. Isn't it? Yes. Now density. What is density denoted by? Yes. What is density is equal to? Mass by volume. Mass is again an extensive property. Yes. So again we are writing extensive property divided by the unit mass. So how much is mass? Again kilogram by meter cube. Isn't it? So that is what is the relation. Something or some extensive property divided per unit mass, some extensive property divided by some unit mass is again an intensive property. Right. So we'll next, after the open system, closed system, isolated system, we have studied a concept called intensive properties, which are mass dependent, and extensive properties, which are mass dependent, and intensive, which are mass independent. Now gradually we'll go into the topic, that is what are state functions and path functions. So once we know this, it's easy for us to apply in all the cases, right? So suppose there is one system, right? There's one system, this is one system 1. Now from this particular thing, what is this system doing? Not one system, one part which we are going to study. So this is at one stage 1. It's initially started the reaction. Now once you started heating from stage 1, this system is going to go to a path that is stage 2. Now this path is called, that whole thing is called the pathway or the path. Now what is state function? And this is called initial stage, and this is called final stage, and this is the path to which it follows. Now the test tube you're heating, you're going to certain temperature, you're getting product. Now according to the state function, state functions are those which depends upon the initial stage and the final stage, not on the path, are called state functions. Let's write that. State functions are those, okay, are those which depend upon initial stage and final stage. Depend upon initial and final stage are called state functions. Now what are path functions? The path functions are those which do not depend upon initial and final stage, but they depend only on the path, right? So what are path functions? Those which depend only on path, not on the initial and final stage. Okay, initial and final stage. Remember. Now what are the examples of the state function, right? So basically, first I've given you the nomenclature, different what terms I will be using. I'm picking those. The first important thing is S. So try to learn the nomenclature and come here. What is S here? S is nothing but entropy. It is a state function. Next, H. H again is called enthalpy, which is a state function. E, internal energy, which I told you, internal energy now given in the nomenclature already, right? T, temperature. P, pressure, right? So the different examples like that which come under state functions, but the one which depends upon the path, that is work, heat, all these will only depend on the path, not on the initial and final condition.